In this video, we're going to talk about exploration number 1, which went through the characteristics of linear functions 2.2.5. If you did not do that Desmos exploration, please go back to Google Classroom and do the 2.2.5 Desmos exploration. Then, if you're still confused, come back here and I'll go through some of the important characteristics. So let's first talk about increasing and decreasing lines. So increasing and decreasing lines we're going to look at from left to right to be able to tell which they are. A line is increasing if it goes up from left to right. So one that looks like that would be like this. So as I read left to right, that line goes up. A line is decreasing then if it goes down from left to right. And a line is decreasing that looks like this. As I read left to right, that's going down. We have two lines that exist that are not increasing or decreasing. One is a horizontal line that doesn't go up or down, it stays flat. And one is a vertical line. Same thing, it does not go up or down as well. We're going to talk more specifically about what slopes of these lines look like. But for now, to add into your notes, it would be helpful to know that horizontal lines have a slope of 0. And it would also be helpful to know that vertical lines have an undefined slope. We'll talk more specifically about how we get those numbers or those answers, but for now, it's helpful to have those in your notes. So then next we talked about what slope actually is. So slope is the level of steepness and the direction of a line. So it says to draw a line that's very steep and then one that's not so steep. So I think of this as how close to a vertical line it is. So the steeper a line is, the closer to vertical. So a very steep line would look like this. Still increasing, but it's very, very steep. A not so steep line might look like this. It's pretty flat, not so steep. And then our final part of the exploration went through our intercepts. So it asks, what is the x-intercept of a line? That is where the line crosses the x-axis. And similarly, a y-intercept is where the line crosses the y-axis. And so wherever those points are going to cross, that's where our y and x-intercepts are going to be. So it says to draw a line with an x-intercept of 3 and a y-intercept of -4. Well, I can just mark where those 2 points are. So this is my x-axis, and this is my y. So it has an x-intercept of 3. I need to cross here. And then a y-intercept of -4, I need to cross down here. And so I can draw a line that goes through those 2 points. Make sure yours is straighter than what mine looks like, but you get the point. And finally, there's a very special way that our x and our y-intercepts are written, and these are always written as coordinate points, which means that they always have an x comma y. Specifically, x-intercepts will always have the number of the intercept first and then comma 0, and y-intercepts will always have 0 first and then the number of the y-intercept. So it says to label each of these points. I am going to do my y-intercepts in blue. So down here is where it crosses the y-axis. I want to go down and count where that's at. So I go over none, which is why that first number is 0. So I'm going to type this as 0, comma. And then I want to count down to wherever else it goes. So 1, 2, 3, 4, 5, 6. So I should have 0, comma, negative 6 because I went down. And that's my y-intercept. So now I'm going to do my x-intercepts in red. And so the x-intercept is where it crosses right here. And again, I'm going to count over to the number, which is 1, 2, 3. And then I'm not going up or down any, so that's 3, comma 0. And that is our x-intercept. So I hope this gave you a little better of an idea of these characteristics that we want to make sure we know for all of our linear functions. Thanks for watching.